Hi everyone, in this lab, let us deploy Amazon EKS cluster with add-ons. Let's get started. In the previous lab, we deployed the code pipeline to deploy the infrastructure as code, right? So we have two stages, GitHub, which is the source code stage, and the second one is the code build stage. This is where we run the Terraform init, plan and apply to deploy the infrastructure. Now using that pipeline, let us deploy the actual cluster and the required add-ons. So we have the EkS cluster, and then we'll deploy the EBS CSI driver, which is deployed as a deployment controller in EkS cluster, and this will talk to the EBS service in the cloud to create the EBS based PV and PVCs. Then we will deploy EFS CSI driver to create again PV and PVCs with the EFS service again, which is in the cloud. Okay, and apart from these two CSI drivers, we'll also deploy the Carpenter, which is a very powerful Kubernetes cluster autoscaler from AWS, and Carpenter will use the EC2 Fleet API directly instead of talking to the autoscaling group. So that's why it will provision the nodes very fast. And there are a lot of other benefits of Carpenter that we'll discuss separately, but this is how we deploy the EKS cluster and few simple add-ons to start with. Okay, now let's go to the code and deploy this. This is the lab guide. We have already gone through the previous lab. Now we are deploying the EKS cluster with add-on. So in this lab, we'll be creating this VPC as a subnets, then creating the EKS cluster using that VPC, deploy the metric server, which is required for scaling the workloads, then Carpenter, EBS and EFS CSI driver. So first we need to go to that folder. So I'm already in that folder. So we see the lot of Terraform files here. Then we will configure the terraform.tf vars with the required configuration data, right? So one of them is basically number of ages to consider. Let's go to the tf vars file. This is the tf vars file. Here the region is US East 1, and this section deals with the VPC configuration. I'm specifying the number of ages to 2. Instead of 3 ages, I'm using 2 because for data processing workloads like Spark, I need to consider lesser number of ages to reduce the cost for the inter-AZ cost, and also to improve the latency between the executor and the the driver parts, right? And the VPC header size I'm using /20, which is basically 4000 IPs. This is because many organizations may have constraints in using a larger header size for VPC from RFC 1918 series. So in this case, I'm using 4K and dividing that header block into multiple subnets for public, private, for the control plane, data plane, and database subnets. And I'm allocating additional sliders for the VPC, which is from 100.64 series, and there are two sliders, each of size /16, so that is 65,000 IPs times 2 AZs, so which will be 1.3 lakhs IPs. So this is a good number of sliders available. Good number of IPs available for the nodes and the pods in the cluster. The next one is basically the EKS cluster configuration. So the name of the cluster is this. Data on EKS-Spark 1.29 latest version at the time of recording this. Then I've enabled few flags to enable certain add-ons. So one is a cert manager, CSI driver, Carpenter, cluster proportional autoscaler for the core DNS, metric server for HPA and other scaling controllers. Then AWS load balancer controller for ingress, right? Now let us go to the code and see how we have configured the rest of the components. So this is the backend. So the state for the Terraform will be S3, and this is the folder. Then this is the YAML file for the build spec file for the code build project that we saw earlier in the previous lab. So this is where we are deploying the Terraform templates into the cloud. Then this is the EKS variables. So quite a few variables for defining the EKS name, cluster name, version, and things like that. Then this is a local file. The main.tf is very important. This is where we'll be configuring the EKS cluster and the add-ons. So if you see, this is a provider configuration, and then Carpenter, Kubernetes, Helm, kubectl, all the three are configured to access the cluster. And the main one is this. So I've created one more module called Spark Data Pipeline and EKS. So in the same file system, and I'm configuring this module with few variables, right? One is the region, cluster name, version name, and also the VPC configuration, like what is the VPC CIDR, how many subnets I need to create, what is the size for each of the subnets, all of that I'm programmatically creating it, because every cluster might have a different requirements with respect to the subnetting, right? And this is where the EKS Addons configuration looks like. So I'm passing this variable. I enabled true for most of these flags in the TF-vars we saw just now, and so I'm just calling this module, and when I instantiate this module with this particular parameter, so it has to create EKS cluster and then deploy these add-ons to the cluster. Okay, so this is what it is. Now let's proceed further, and there are few output variables here, some version and VPC variable. These are all the regular stuff that we see to configure the module, right? So let me now run the Terraform init and plan and apply. So now I need to run the Terraform init and Terraform plan and apply to apply all these Terraform templates into the EKS cluster. So I will not be running the Terraform init on the command line here, because everything has to be done as a part of the code pipeline that we have built earlier. So all of this code that we are seeing here is already part of my GitHub. So what I will do is I will just push this code to the GitHub, which should trigger the pipeline. So for example, now the upload is happening. Now if I see a refresh of the GitHub, now you see that the code is updated. Now if I go to my pipeline and look at the execution state, it should start the execution now. Let us wait for a few seconds. Let me refresh this once. Yeah, now we see that the pipeline got triggered just now, and it has been succeeded. Now there is a build phase. I'll just keep a pause because it may take some time. So the build stage completed successfully. As you see, there is a green color which indicates it's successful. So the entire pipeline completed successfully. Now let us look at the logs for the build. So if you look at the logs from the code build stage, it exactly shows the same output like we saw earlier when you do the Terraform apply yourself on the command, right? So it is displaying the cluster endpoint and the command to create the kube context, and the VPC it has created, the subnets, the CIDR blocks, the subnet names. So all of that useful information it is showing on the Terraform for quick reference, right? Next, we need to create the kube context to access the cluster. Okay. So this is a command to create the kube context. So you can either run this or run this. So if the terminal on which you are running this command is already configured with this role, okay, then you can directly run the first command. But in case if the terminal of the EC2 machine or Cloud9 where you're running these commands is not configured already, then it's better to update the role here, because you want to assume this role to access the cluster, because this is the role which is used to create the EKS cluster. So we have to use the same role. Otherwise, the IAM identity which is configured currently on the terminal, it may be user or a different IAM role. If that is different than this role, then we'll not be able to access the cluster, and it gives 401, which is another unauthorized error, right? So I've already run this command, the second command, to access the cluster. Now let me just see if I can access the nodes and see the nodes in the cluster. So I see that there are 4 nodes already available in the cluster. So let me also show the EkS cluster in the console just to see how it looks like. So this is the cluster which is created with 1.29, and if I go to compute, there is one manage node group which contains 4 nodes, and this is a version of the AMI, and so we can see that 4 nodes are already there in the cluster. If you go to add-ons section, you will see the Amazon VPC CNI deployed as a managed add-on. Like that, there are 7 add-ons already added. It's always a best practice to use the add-ons instead of we manually managing it, right? So add-ons are there. The cluster is created with VPC, the right subnets. Now let us check all other components like EBS, EFS, and the carpenters are deployed or not. Let us proceed to the console. So here, let's go through the commands and run. So this shows there are 4 commands, 4 nodes in the cluster. Now let us run the commands one by one. This one is to check the EBS CSI driver pods. So there are 2 pods running. So basically in the cube system namespace we are running this, and this is fine. Now let me go to the EFS driver. EFS is also running fine. Now I will check for the carpenter. Carpenter is also running fine. So the components that we deployed, the EBS, EFS, and the carpenter are running fine in the cluster. So this, with this, we conclude the lab for EKS cluster and the add-ons. In fact, we also deployed one node pool in carpenter. Let us check that also. There's a node pool with name default. So if you wanted to see the configuration of this node pool, you can just type -o YAML, and you will see that the configuration is there, where we specify certain um, computing requirement in terms of the limits, the template, labels, specification of what type of instances we need to have, and then there is a EC2 node class which specifies the configuration for the EC2 machine that Carpenter brings. So all of that is configured. So one default node pool is also created. Okay, so now that we have deployed the EKS cluster and the add-ons, let us proceed further to deploy the observability stack.